simple. Evaluate the limit as x goes to 0 of 1 over x plus 3 minus 1 over 3, all divided by x. First question we ask ourselves is it a normal function? So, is it normal? Well, yeah, you can guess by my hint of no. If we plugged in 0, 1 over 3 minus 1 over 3, 0 on top, divided by 0 on bottom. No, definitely not normal. So it is not normal. Oh no, what are we going to do? Well, the next thing we ask ourselves is, can we cancel factors? So can we cancel? Not easily, right? 1 over x plus 3 minus 1 over 3. Really don't see any easy ways to make cancellation show up there, so probably not going to be able to cancel, at least not easily. So our next question is, last time we asked ourselves, can we rationalize? Well, there's no radicals here, so we can't rationalize, but we can take a hint from the idea of rationalization. The idea of rationalization was multiply the top and the bottom by something that makes some part not weird anymore, not as strange to deal with, so hopefully we can get cancellation to appear later. Well, what would make the top, the thing that's really strange about this is we've got fraction over fraction, right? We don't like fractions and fractions. So how could we get rid of some of those fractions by multiplying? Well, the easiest way to get rid of the denominator in the top is to just multiply by the denominators in the top, right? So if we multiply limit, so I'll rewrite the thing out, limit as x goes to 0 of 1 over x plus 3 minus 1 over 3 all over x. Well, what would get rid of the x plus 3? Well, x plus 3 would get rid of the denominator of x plus 3. What would get rid of 1 over 3? Well, multiplying by 3. So we can get rid of both of those denominators by multiplying that whole top by x plus 3 times 3. That'll cancel out each of the denominators as we work through it. And remember, it's always going to multiply the whole thing. When we multiply the quantity because we have to have distribution showing up. And on the bottom, we'll have to have the same thing because otherwise we're not multiplying by, we're changing the expression. We can't change the expression. X plus 3 times 3 over x plus 3 times 3. Great. Our limit continues. Limit as x goes to 0. What do we get on the top? Well, x plus 3 times 1 over x plus 3. Those cancel out. We're left with just the 3 left over, right? So x plus 3 times 3 on 1 over x plus 3. The x plus 3 cancel out. We're left with just 3. Minus when x plus 3 times 3 hits 1 over 3. Well, the x plus 3 doesn't do anything, but the times 3, that cancels out, so we're left with minus quantity x plus 3. All right, now we could expand the bottom, but that won't actually help us, right? One of the ideas we're going to hopefully manage to get to is to figure out a way to cancel things. We couldn't cancel things easily by factoring, but hopefully we'll still manage to cancel something at some point later on. So we don't want to expand factors. We want to actually keep up this process of keeping things in factors. So let's not put anything together. We'll have it as x times x plus 3 times 3. So at this point we see x plus 3 on top and x plus 3 on the bottom, but we have to be careful. Don't cancel stuff, right? We can't cancel because there's still a subtraction sign on the top. We have to have the whole factor. So we keep working to simplify. Limit as x goes to 0. 3 minus quantity x plus 3. Well, the 3's will cancel out and we'll be left with just negative x on the top. Negative x on the top. Divide by x times x plus 3 times 3. Great. Limit as x goes to 0 of negative x over x times x plus 3 times 3. At this point we go, hey, we can cancel some stuff. This x and this x cancel, and we're left over with the limit as x goes to 0 of negative 1 now, because it just canceled out the x, not also the negative, times x plus 3 times 3. Now, we ask ourselves, now that we've managed to cancel something, if we were to plug in a number, would we have something weird happen? Would it be normal now? If we plug in 0, we get negative 1 over 0 plus 3 times 3. Hey, doesn't look like we're going to be having dividing by 0 any issues anymore. It isn't weird anymore, so we can just plug in. So we have this is equal to the negative 1 over 0 plus 3 times 3. Once it's not weird, we can plug in because now it is effectively normal. And when it's effectively a normal function, you can just plug into it with your limit. Negative 1 over 3 times 3. So that gets us negative 1 over 9. And there's our answer. Great. All right, so at this point, we've got a really good understanding for how to figure out how limits work. The basic idea is, all right, I've got a limit that is normal and doesn't have anything weird happen. Easy. Just plug in something, crank it out, see what number you get out. That's what the limit is. Because normal means that your expectations will be met. If it's not normal, if there's something weird happen, you try to manipulate things. You either pull out factors, you multiply the top and the bottom, you do something where you're allowed to cancel factors later on, and then you check and see, okay, now that I've canceled out the factors, is it possible for me going to plug things in and have it be normal effectively? Can I now plug in now that there isn't hopefully a weird thing happening? Sometimes there will still be weird things happening. All the examples we saw here, we canceled out anything that would cause weird stuff to happen, but sometimes you wind up still having weird stuff no matter what you manage to cancel out. And in that case, it can help to check a graph and go, oh, I see, it's going to blow out to infinity, or something like that, and you'll say, oh, it's never going to work. But a lot of the time you can cancel stuff out and you can go, oh, okay, now it's effectively behaving like a normal function, so I can plug in the x value that I'm going towards and just crank out an answer. All right, we'll see you at Educator.com later. Bye!